Yeah, so hey everyone, welcome to our Aptitude Sessions 2. So we will be continuing from where we left yesterday, that is Venn diagrams type 2. Yeah, so what exactly is Venn diagrams type 2? That is same figure for different groups. So you will have the same geometrical figure, unlike type 1 and type 3, where type 1 had different geometrical figures for different groups, and type 3 had same geometrical figures for different set of groups. But all the more, it was again you would establish a relationship between the groups, not between the elements of the group in type 3. But in type 2, again, you're going to deal with the elements of the group of various groups rather, and the same figure will be used. That is circles. That is the most commonly used geometrical figure when it comes to representing. And this is exactly where your set theory of mathematics begin. So there are a few things that you need to know before we start getting into problems. So first is the union symbol, which is known as U. So for better understanding or not getting a confusion of universal set, that is U and the union symbol, universal set has U with the dashes on both the sides, whereas U, which is the OR symbol, is not having, it is just a plain symbol. Reverse of OR is AND, that is ulta U or upside down, U in upside down form. And OR is nothing but logical addition, and is nothing but logical multiplication. And U can sometimes be represented as mu as well, that is universal set. And number of elements given to a particular group or anything will be represented as n. So if you're telling number of elements belonging to set A, you will write n bracket of A, and so on. So universal set is nothing but the complete set of elements taken into consideration. That can include those elements that belong to the mentioned groups, also elements that do not belong to the mentioned groups. It can include either ways. All of that comprises of the universal set. And there is something called as null set that is represented by phi. So what exactly is a null set? Is a set that is empty. It means that the set may or may not exist, but even if the set exists, then the elements are zero. There is no elements at all. Number of elements are zero, no element exists. Okay. And coming to certain important formulae, A, that is any given set is nothing but U minus A complement. So what is A dash or A complement? It is also known as A bar at times. So what exactly is A complement? That is all those elements which are not a part of A. For any reason, they are not a part of A. If I have to give you an example here, yeah. See, these elements that belong only to C, which has nothing to do with A, those elements are not a part of A, and so on. So what is A? The set A, it's nothing but universal set, that is list of all elements minus A complement. That is list of those elements that do not belong to A. So from the total set, if you remove those elements that do not belong to a particular set, you land up with purely that set. That is, there is no interjection or intersection of that set with any other set. All right. Next is A union B, that is A plus B minus A intersection B, the most commonly used formula everywhere. And that is A union B. So what happens is when you're taking the entire A and entire B, the intersection is also considered twice. So minus one time of the intersection. All right. That is also same as A minus B plus B minus A plus A intersection. This we will learn once you will understand better once we start difference of set. That is A minus B is nothing but difference of set. A intersection B, when you have A union B, just reverse the formula. That is wherever you have union, you place it with intersection. That's it. So you have union, you place with intersection. You have intersection, you replace it with union. Signs remain the same. A union B, the whole complement. Yeah, you can also write it as U minus A union B. But there is another formula as well, U plus A intersection B minus A minus B. That is A union B. All those elements that belong to A and B is A union B. So A union B whole complement is those elements that literally do not belong for any reason, it does not belong to A and B. Fine. And how will you find out this universal set U? That is A plus B minus A intersection B plus A union B the whole complement. So A plus B minus A intersection B, that is A union B. Okay, I mean, I'm taking with consideration to only two sets. You can also have it for three sets, but respective intersections and unions will come in. You will know when you start getting problems of this kind, you'll be able to solve. It is not going to be a big deal. So yeah, all those elements, that is A union B. So intersection is counted twice, so minus one time of it. So that is A union B. All that belongs to the two sets A and B, and all those elements that do not belong to that set A and B. Let us say the circle C didn't exist for now. So you have A union B, and the intersection comes twice. I told you we are minusing it once. So you're getting A union B. That is all the elements that belong to A and B. A or B, A and B, or all the ways, fine. But what about the remaining elements? They are also part of universal set. So A union B, the whole complement. In fact, you can even substitute this A plus B minus A intersection B with A union B. You can actually substitute it. Fine. Yeah, A difference of B. So what is A difference of B mean? That is all the elements that belong to set A but do not belong to set B. So even the common elements will not be considered. So only the elements that are purely a part of A and not at all a part of B. Let's say we had three sets like A, B, and C, and you wanted to find A difference B. So what would you do? Would you have to consider C? Yes, because you only mentioned A difference B. You've not mentioned about A difference B or C or anything like that. Fine. So A difference B is again all elements that belong to A but does not, I mean, only belongs to A and does not belong to B. So it can all, that is A minus A intersection B, also written as A intersection B complement, that is also equal to A union B. Fine. That is A minus A intersection B again comes as A union B. And this A minus B can be and this one A, that is this purely this set A, if and only if this A intersection B is equal to 0. The next formula is A triangle B, that is symmetric difference. So be sure minus is difference, triangle is symmetric difference. So what do we mean by symmetric difference? Is that list of those elements that belong only to A along with the list of those elements that belong only to B. Both cases. Okay. So that is what.
Can you please repeat it?
Sure. Asymmetric difference of B is nothing but list of all those elements that belong to A and not B. Fine. That's the first part of the formula. That is, that belongs to only A. Fine. The intersection is not considered, only A, purely A. And list of those elements that belong to B, only B. So A and B. Only these two things, that is pure A plus pure B. You're not taking into consideration the interjection or the intersection. Okay, the next is A minus B intersection C is again, you're using the basic mathematical laws. So it is A intersection C minus B intersection C. A minus A is nothing but 5. So if you are taking A, what is A minus A? List of all those elements in A which do not belong to the second part of A. So all those elements that belong to A but does not belong to A, it again contradicts. You will get all these elements again, minus these elements, you will get 5. That is, you will land up with a set which has no elements at all. So hope the formulas are fine.
Yes, ma'am.
Okay. So moving on to the first example, in a class of 80 students, 30 students, just give me a minute. Okay. Fine. In a class of 80 students, 30 like tea, 35 like milk, and 25 like coffee. It is also known that 15 like both tea and milk, 17 like both milk and coffee, 14 like both tea and coffee, and 9 students like tea, coffee, and milk. Okay. So what have they given? Three different categories or three different groups known as three different sets. So what is it? Tea, coffee, and milk. Tea, coffee, and milk. So they have given in a class of 80 students. So that is your universal set is nothing but 80. 30 like tea, 35 like milk, and 25 like coffee. It is also known that 15 like both tea and coffee. So yeah, tea and okay, here. No, sorry, 15 like tea and milk. So 15 like tea and milk. 17 like both milk and coffee. So milk and coffee. 17 and 14 like both tea and coffee. 9 like all the three. So what will this part be? 9. And what did they say in the first part? That is 15 like both tea and milk. This entire thing, 15, where 9 is a part of that 15. So if you want to know this answer, you should go for 15 minus 5. Alright. And similarly, for this part, that is those who like milk and coffee, it is 17. So 9 is a part of the same 17. So how should your answer actually be? I mean, how do you calculate it? 17 minus 9. Similarly, how many like tea and coffee? That is 14. So 9 is a part of that same 14. So your answer should be somewhere 14 minus 9. Okay. Yeah. And how will you calculate these regions? You will take 9 plus 14 minus 9 plus 15 minus 9. You will land up in an answer. So 30 minus this complete answer will give you this region of only students who only like tea. Yeah, so this will be taken. Okay, let's take this region. So what will it be? 30 minus of 9 plus 14 minus 9 plus 15 minus 9. Okay, so understood the logic because given total is 30. This 9 is a part of this 30 and 14 minus 9, this part is also a part of this 30. 15 minus 9, this is also a part of the same 30. Okay, so what remains will be this, difference of 30 minus the sum of these. Hope the calculations are fine with you all. Yes, no,
Yes, ma'am. Yes, ma'am.
oh, fair. If so, then quickly calculate and tell me what are the answers you are getting.
And 14 is 10, ma'am.
Sorry, I didn't hear you.
10, 10.
Where you should tell me where exactly is 10 or what is 10.
P.
T is
Number
30.
of students who drinks only T
Ah,
after the calculation.
yes. It's not after calculation, it is only T.
Only T.
Yes, this is 10. Fine.
I think only coffee is 3.
Yes, ma'am, 3.
Okay, so how about milk?
And 12. Only is
12.
Correct. So this answer is 9. This answer is 5. This answer will be 6. And this answer is 8. Okay. Yeah. So I hope you guys have taken down the previous diagram because all the questions or example questions are based on the same diagram. So moving on to the example, what is the total number of students who like neither tea nor coffee nor milk? So you have tea, you have coffee, and you have milk. And you have this universal set. So what have they asked? Those students who belong to this region. So these
Now,
students, yeah,
when you have universal set is 80
yes,
and only tea is 10, coffee is coffee is 3 and milk is 12, right? After
yes,
adding all three, can we minus it with 80 so that we'll get the people who neither drink all three. Is that correct?
yes, your approach is correct. That is exactly how it's supposed to be. Yes, so you have your universal set given as 80. So you will go for universal set minus those who have taken tea, those who added with those who have taken coffee, those who have chosen milk. This will give you the answer for the complement of
55.
those who do not like. Okay,
And
so
it's
yeah,
55 now.
I didn't hear you.
It's 55.
What is 55?
Students who mental health in coffee.
I'm so sorry, your voice is breaking. Could you just repeat that?
No, I'm just asking if the answer is 55.
Oh, the final answer?
Yeah.
No. This answer, okay, 55 is close, but no, this answer is not 55. This answer is 53. So you 80 minus 53. I hope this diagram is fine. So take
Mom, 10,
10.
12 plus 3, right?
10, 12 plus 3, you left the intersections.
Okay.
You could have taken 30, 35, 25. Even in that case, you could have probably landed up. No, I think that also you will not land. It is not correct. Taking that away. So 10, 12, 3, 5, 6, 8, and 9. All of these you've got to add up. And that answer is going to be 53. So 80, that is universal set, minus 53 will lead you to 27. All of you reached this answer?
Yes, ma'am.
Okay, one person told yes. How about others?
Yes, ma'am.
Yes, ma'am.
Okay, cool. The next example, how many do not like tea? So they may like coffee, they may like milk, but they should not at all like tea. So that is, you have anyway this only t as 10. So whatever is your universal set, that is 80 minus 10. Oh, did I miss out something? Oh, sorry. Yeah, I also missed out.
Ma'am, we
Uh,
should add the intersections as well, right?
you're right, you're right, you're right, you're right. So correct. You need to add the intersections as well. So in that case, where do you land up?
One,
Sorry, I didn't hear you.
51, ma'am.
50, ma'am.
50. Is that your answer?
Yes, ma'am.
51.
51. How 50?
I
Yeah,
think 50 is the answer, 50.
50 is supposed to be the answer. Okay, let's do this. You have 10 here. Okay. You have how many here? You have 5.
5,
You have 9. You have, I think, 6. And
6.
yes, 8. You have 12 and 3 on the other side. Cool.
Oh, sorry, ma'am. Should we find the three intersections also?
I
The
didn't
9
hear you.
number.
9. Yeah.
Okay, ma'am.
Oh. No, I'm sorry. What were you asking?
Ma'am, I missed the middle part, the 9 of it.
The 9.
That may be
Okay.
confused with, yeah.
Mm-hmm. So how many do not like tea? Yeah, so take how many like tea, that is 10, 5, 9, and 6. When you add up all of these, you will land up in 30, if I'm not wrong.
Yes, ma'am.
Correct. 20 plus 10, 30.
Yes.
80 minus 30 is 50. So hope everybody has now landed up in 50. Is this your answer?
Yes, ma'am.
Yes,
Everybody?
ma'am.
Okay, fine. Okay, what is the value of T minus C? That is those students, those students who only like tea but not coffee, but they may like milk. That's not an issue for them. So you have 9, 5, 6, 8, yeah, 8, 12, 10, and 3. Correct? So yeah, how many like only tea but not coffee? So you will be including 10. You will have to include 6.
Ma'am, is it 28?
Mm-hmm. No, it is not 28. You will not consider only this circle, you will not consider. I think I can probably highlight it here.
Is it 54?
54, no. Okay, yeah, you will not be able to include milk as well. Sorry, I forgot to tell that point. The reason is this. Why you cannot include milk? Because milk is a given set here. So whenever you have the given set, you cannot include that also. So 12 will not be included. So minus 12, you will land up in this answer. 10 plus 6, 16. Got the answer?
Yes, ma'am.
Okay. Is there any confusion that is existing? Any confusion? Any doubts?
Yes, ma'am, I have that. Ma'am,
Yeah,
when they are doing minus, like tea minus coffee,
yeah.
you have to include only the element that belong to tea.
Elements, yeah, that belong to T, correct.
And this 6 belongs to both tea and coffee, right?
Not tea and coffee, tea and milk. This is okay. This is tea. This
Okay.
is coffee. This is milk.
Can we include milk when it is not mentioned?
You cannot include the set that belongs to purely people who enjoy drinking milk. You can consider this portion because tea minus coffee when is given for the intersection, for you to understand the intersection. That intersection of coffee will never be considered, come whatsoever. But this 6 is still a part of tea. Agreed, it's a part of milk as well, but it's also a part of tea. So you can't
Yes.
ignore it when no condition for that intersection is given.
Yes.
Hope everybody is clear. No doubts, no confusions.
Yes,
Ma'am, for
ma'am.
the difference,
Mm-hmm.
whenever they ask for difference, is it always only for 2 different sets, or is it possible for 3 different sets also they can ask?
I don't think they can ask for 3 different sets. Even if they ask, you will, let's say they have asked T minus C minus M. So in that case, you will have to anyway take the first two always. T minus C. This you will land up in some answer, let's call
So
A.
it's
A minus M. Even
okay.
then it is that way. So you will consider two sets
Either
at
way,
a time.
either way, the answer will be the first set, right? Like the
Yes.
only first set.
Only first set if it is considering all the three because total number of given sets are 3. Tea, coffee and milk. Total number of given sets are 3. So if you are having T minus C minus M, then you will have, what is it? You will have only 10, that is this part. It is T minus C, this part, plus this intersection with milk, because there is no condition prevailing on this intersection.
Yes, ma'am, understood.
Okay, so hope everybody's confusions are clear. Any more doubts? I don't mind repeating things now because we can do it now. We can repeat it now. No doubts?
No, ma'am.
Okay. Then we'll move to the next example. Symmetric difference of C and M. So what will you do? You will first take C minus M, add that answer with M minus C. Consider the intersection with T because that intersection can be considered, not the complete set, only the intersection.
So 26.
Is it 26, ma'am?
Yes, the answer is 26. Okay, so the confusion or anything created in the previous example will be taken care once you finish this. All of you landed up in the answer 26?
Yes, ma'am.
Yes, ma'am.
Kusum?
Yes, ma'am.
Yeah, okay. Okay, so the last example for today. What is the total number of students who like both tea and coffee but not milk? So you
5.
have
It's 18, ma'am.
who liked both tea and coffee but not milk.
5.
You have 9, yes.
5.
And you have 5 here. It is very evident. You can't add this because this 9 is also the set of people who like milk. So you can't add that 9. You can't add the 6. Why? It's a set of people who again like milk and tea. Milk is coming in. So it's a big no. Again, this set of 8 we cannot add. Why? Because it's a list of people who like both milk and coffee. They've told milk should nowhere come in. So only tea and coffee without milk. It is 5. Understood?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
All right. So anybody has any, before we move to that, you can solve it either by using formulae or if this is working out easier for you, you can go for it. There is no trouble at all. Whichever is easy or whichever works well for you, go with that. Fine. You will know once you start practicing 2 or 3 sums, you will come to know that which method actually works for you. Is it the formula or is it this? So whichever works, because competitive exams, they don't see on the method, whichever method you're able to, analyze and calculate quickly, that will be considered because time matters over there. You will have to keep in mind or you have to keep track of your time. So this is
In fact,
something that,
we can write the direct answer without any steps.
yeah, you can write the direct answer. Aptitude, they don't see much into the steps. Uh, there are extremely rare companies who might ask for your worksheets. Again, worksheet, it's not mandatory for you to use, but they may provide or they may ask you in advance to carry one or two, depending on how much ever you need. The sample sheets or worksheets or rough sheets, whatever you call them as. And if at all you have used them, they might take it back, not for evaluation purpose, but probably for maybe purpose of conducting the exam without the malpractice or anything like that. It's very rare because nowadays most of these tests are proctored and online. Proctored in the sense your audio and video both should be on, and it has its own set of rules where you cannot turn here and there. It'll keep track of your eye movement. and any other background noise or disturbance, then you will be immediately rejected from that test. So all those things will happen. So that is proctored exam, and it happens online most of the places, at least these apti sessions and all. So it's pretty fine. Steps actually don't matter as long as you're able to reach to the correct answer. If you're not able to reach to the correct answer, follow the steps as and when time goes by, you'll be able to progress in such a way that you'll be, instead of 5 steps, you can condense them into 3 steps. Slowly, you will take them to 2 or 1 step. Then slowly, without any other, required step, you'll directly come to the answer.
Yes.
Okay, so that is fine. One thing I wanted to discuss was yesterday's one problem. That is, I think, Sachin, I guess that problem. Yeah, Sachin, that is the second example which we had taken yesterday to calculate. We landed up in the correct answer, of course, but I by mistake mentioned this one 6 plus 3. Sorry, it is 6 plus 6. Okay, I had mentioned root of 9 square. No, it is supposed to be root of 12 square. Root of 12 square plus 5 square. That is how we land up in the answer of 13 meters. Yeah, all of you got the answer right, but I kind of made a mistake, so I thought I will correct here. Fine. If at all you made the same mistake there, correct it.
Yes, ma'am.
Okay. So any doubts in Venn diagrams type 2? Any
No,
doubts,
ma'am.
any confusions?
No, ma'am.
No doubts.
Nidhi, how about you?
No, ma'am.
Okay, so no doubts, no confusions. You're fine with direction sense, type 1, type 2, and type 3 Venn diagrams. All of you?
Yes,
Yes,
ma'am.
ma'am.
Okay. And any doubts in the practice questions PQ that was given yesterday, PQ 1
Ma'am,
and 2?
we solved it. Could you please show us the answers so we can just verify if we're right or not?
Sure. I will share the answers on the WhatsApp window. Not a problem.
Thank you, ma'am.
Yeah. So you want only the final answers or you want the complete solution as well?
I think final answer will be fine.
How about others? Everybody?
Yes, ma'am.
Yeah, ma'am. Final answer is okay. Only final answer.
Okay, fine then. All right then. Thank you so much for joining today's session. Let's meet in the next session.
Okay, ma'am. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.